Hello everyone. So welcome to this talk on dynamic programming. So this is like one of the most discussed topics in the world of data structures and algorithms. And I just want to introduce the topic over here and slightly introduce it with a very easy example. So let's uh, let's pick an example. For example, you have been told that you want $6 or something like that, and you have the coins of denomination, for example, 1, 3 and 4. Now you can use these coins any number of times, but the question is that you want to use the minimum number of coins to get to 6. So ideally, like, the first solution that comes to mind is like a greedy solution. Like, you will first try to reduce it by the largest coin you have, because you want the minimum number of coins. So you would try to use like 4, but that would give you like what, 4 plus 1 plus 1, which is like 3 coins. But as you can easily see, that the answer over here is 3 plus 3, which is 2 coins. So this approach, where in every iteration we try to find the best solution, it's called the greedy approach. And this approach over here, this is the correct solution for this problem. But how do we arrive at it and in a very efficient way is what I want to discuss. We can try to use recursion over here. For example, when you want to produce, like, we can have a function called, say anything, say my function. What is this function supposed to do? It will take as input the number you want to produce, and its goal is to give you the minimum number of coins. Now say if you have my func of 0, so how many minimum number of coins do you require to produce 0? You know it's 0. If you want to use my func of 1, how many minimum number of coins you need to produce 1? Exactly 1 coin. For 2, you need 2 coins, 2 of these 1 coins. For 3, you can again just use this one, third coin, so it will be again 1. For 4, again 1, and so on and so forth. So to produce 6, what you can do is a minimum of my func. You have 3 denominations, so 6 minus 1, you are using this first coin since you have used 1 coin, or you can either do 6 minus 3 plus 1 since you are using this coin, or you can do this. This will be a solution. But over here there are certain issues with the recursion tree which I would like to highlight. So, or I can just draw it over here. Like, if you focus on this over here, when we are trying to do the recursion tree for 6, let's focus on, for example, one of the paths. Like, you are getting either 5, you are getting 3, and you are getting 5, 3 and 2. These are the recursion trees. Like in 5, you can again get, if you use the coin number 1, you will get 4. If you use 3, then you will get 2, and if you use 4, you will get 1. Again for 4, you can use either 1, 3 and 4. So if you use 1, you will have 3. If you use 3, then you will have 1. and if you use 4 itself, then it will be 0. For 2 again similar. So if you notice this, we have 3 over here, we have 3 over here as well. And for this 3 we can again calculate, like if we want to use the first coin it will be 2, if you use the third one it will be 0 over here. The point over here is, when you have such large numbers, over here we have chosen a very small example, we are calculating certain number multiple times in a recursion tree, which will cause an extreme number of computations, which is not ideal for us. What we want to do over here is store this value somewhere, that so we can just store it in an array called values or something, and we can store it that once we have calculated the value for 3, that my func value of 3, we can just store it in this array, something like, yeah, some value over here, something like this, so that the next time when we want this value, say in this, so we have calculated, for example, say this section of the tree, and we are coming to this section to calculate this part, this second part. We don't have to again go inside the tree of the 3 to be calculated. We can just use the result that we calculated over here inside over here, and we are saving these computations. That is basically the principle behind dynamic programming. I hope you enjoyed and liked this video, and stay tuned for future videos.